Have you ever just picked up a random rock and, really looked at it, past the dirt, past the rough edges, and wondered how in the world something so ordinary can be hiding such perfect geometric beauty inside? Well, let's dive in, because today we're uncovering the secret rules that let minerals build themselves into these incredible masterpieces.
Just look at this thing. That wasn't carved by a person. That's a mineral that literally assembled itself, atom by atom, deep inside the earth. It just makes you wonder, right? How does nature build something with such flawless angles and structure from, well, basically just rock and dust? That's the exact mystery we're solving today.
So to figure out how these crystals get built, first we have to know what they're built from. What are the most common building materials lying around on our planet? Think of it like a detective story. Our first step is to line up the usual suspects.
And it turns out the answer is surprisingly simple. When you look at what our planet's crust is made of, it's not an even split, not even close. Get this, a whopping 92% of it is made of just one family of minerals, the silicates. So just like that, our investigation gets a whole lot simpler. The key to this whole crystal mystery, it's got to be with them.
Okay, so that leads us to the obvious next question, right? If 92% of the rocks under our feet are silicates, we really need to know what they are. What is this fundamental component, this master key to understanding pretty much everything?
Well, here it is. This little guy is the ultimate Lego brick of the mineral world. It's called the silica tetrahedron, and it's super simple. Just one little silicon atom in the middle with 4 oxygen atoms attached, making this perfect little pyramid. This tiny repeating shape is the foundation for almost every rock you've ever seen.
But hold on, if almost all minerals are made from the exact same block, how do we end up with thousands of different kinds? Shouldn't they all look the same? Well, the secret isn't the block itself. It's all about the incredible ways those blocks can link together. This is where nature gets really creative.
And you can see exactly how that works right here. See on the left, those little tetrahedra link up corner to corner, and they form a long single chain. But now look to the right. When you take 2 of those single chains and link them together, you get a double chain. It kind of looks like a ladder. And that one tiny change in the design, boom, you've just created a completely different class of minerals with totally different properties.
And this one simple idea of linking creates all the major structures. You can have the tetrahedra as isolated independent blocks, which gives us minerals like garnet. You can snap them together into those long single chains we just saw to make pyroxenes. Link the chains side by side, and you get flat sheets, making flaky minerals like mica. And finally, if you link up every single corner, you get a super strong 3D framework, which is what you find in quartz. It's amazing. One block, so many different architectural styles.
Okay, so we've got a handle on how minerals are built. Awesome. But that brings up a new problem. If you find some mystery crystal out in the world, how do you actually identify it? How can you peek inside and see that atomic architecture we've been talking about? Well, the key, believe it or not, is light itself.
When we look at a mineral, the first thing we notice is probably its color. But color, in the mineral world, can be a total liar. Quartz can be pink, purple, white, you name it. The real, definitive clue isn't on the surface. It's how that unique internal structure, those chains and sheets, actually bends and changes the light that passes through it.
And this whole interaction is based on a concept called refraction. It's pretty straightforward, really. When light travels from air into a denser material, like a crystal, it slows down and it bends. Think of the mineral's atomic structure as a unique little obstacle course for light. And the specific way it slows and bends that light is a direct result of its atomic arrangement. So how do geologists actually put this to work? Well, first, they slice a piece of rock so incredibly thin that it becomes transparent. Then, they shine a very precise, controlled beam of light through it. The mineral's internal architecture does its thing, bending that light in its own special way. And then they measure the exact amount of that bend. That measurement is called its refractive index. And that number, it's a unique fingerprint. No 2 minerals have the same one.
So let's bring this all full circle. We've journeyed from the scale of the entire Earth's crust all the way down to the atomic level, and now we're seeing how that invisible atomic world creates a signature that we can actually see and measure.
So here's the bottom line, the main takeaway from all this. A mineral's invisible atomic structure, the way all those little tetrahedra are connected, is what directly creates its unique measurable signature in light. The beautiful shape you see on the outside and the way it bends light are 2 sides of the very same coin. One causes the other.
So the next time you pick up what seems like just an ordinary stone, I want you to remember what's really going on in there.
It's not just a lump of matter. It's a microscopic city of perfect little pyramids, all linked together by a hidden set of rules, creating this perfect, silent architecture, just waiting to be seen.